So we've discussed the fact that this example table that I gave you on the graphic organizer did not at first glance seem to have a constant change in the x's or the y's, but if you compared the change in y to the change in x, you were able to see that it did always reduce down to the same change. So what you got out of this, hopefully, was that the slope of this table right here was 1. Change in y compared to the change in x, change in y compared to the change in x, change in y 2 compared to the change in x 2. So 2 over 2 was 1, 4 over 4 was 1, 2 over 2 was 1. So we got a slope to be 1. And then, of course, we talked about, we know if we want to write an equation in slope-intercept form, we need a slope and we need a y-intercept. A y-intercept is the one that has a 0 for an x value. So we can see on the table right here that the y-intercept is 2. And then writing an equation y equals m1x plus 2, which is just the same thing as saying y equals x plus 2. That's in slope-intercept form. If they ask for it in standard form, then you can watch the equation on how to change this to the standard form. I'll do this one real quickly. Negative x plus y equals 2, and then we never like our x term to be negative, so we multiply everything by negative 1, which just changes all the signs. So there's my standard form equation. I have another one over here, another example that I can work. So we'll see right here, let's see what the change from 3 to 2 is a change of negative 1. I got ahead of myself and put plus 1, so that's a negative 1. Change from 2 to 1, that's going down by 1, that's going down by 1. So it looks like each one of the y values are going down by 1. And then from negative 3 to 0, that's increasing by 3. That's increasing by 3. From 3 to 6 is increasing by 3. From 6 to 9 is increasing by 3. So the slope, it looks like, is the change in y over the change in x, which was a negative 1 over a positive 3. So it looks to me like the slope is negative 1/3. Do we have a 0 term? We do. We have x is 0 and y is negative 2. So we can just tell by looking right there that the b is 2. And we can write y equals negative 1/3 x plus 2. And then, of course, we can change that to standard form. Add the 1/3 x to both sides. Sorry, I should show my work. I was doing it mentally. That adds to 0. Multiply by a 3, because that was what my denominator is, so that becomes x plus 3y equals 6. Now it's in standard form. This is what it looks like in slope-intercept form. What if that number hadn't been there? So what if it had been negative 3, 3, let's say it just been 3, 1, 6, 0, 9, negative 1. We could have still found the same thing that we did before. We still would have found this was a change of 6. This was a change of from 3 to 1. That's negative 2. This is a change of 3. Minus 1. Minus 1. This was a change of 3. So we would have seen right here the change in y, negative 2. Over the change in x, which is 6, that reduces down to negative 1/3. And we got 1/3 right there, negative 1/3 right there. So we still would have got the slope to be negative 1/3. But if they didn't give us the y-intercept, then what would you do? You would use point slope form. And point slope form works with any point. So you could take this point right here or this point or this. It doesn't matter which point. I usually take the first one that's on the table. negative 3, 3 is my point. I call that x1, y1. My slope, I've already found that to be negative 1/3, and then I just simply plug in the formula. The formula is y minus y1 equals m times x minus, and then minus a negative 3. And hopefully you remember that x minus a negative 3, we end up writing it as a plus, minus a negative ends up writing as a plus. So this would be a point slope equation that would work for this table that they gave us right here if we didn't already know what the y-intercept was, and we could just pick any point. And then, of course, if you wanted to distribute that, oh, I'm sorry, that should be a negative. I didn't plug in the negative. Negative 1/3 x, negative 1, and then add 3. You get y equals negative 1/3 x, negative 1 plus 3. What is that? Plus 2, which is exactly what we got up here. So this equation and this equation are the exact same equation. So you write it in point slope form and then convert the point slope form into slope intercept form, and you get the same thing that we got from knowing that the y-intercept was 2 at 0, 2.